Group 17 elements, halogens, fluorine family. The general electronic configuration is Ns2Np5. There are 7 valence electrons. The members are fluorine, chlorine, bromine, iodine, astatine and tennessine. Here astatine and tennessine are radioactive. Tennessine is a synthetic radioactive element with a very short half-life, milliseconds only, hence its properties are not established. Astatine is also radioactive. We know very little about astatine also. All the group 17 elements are non-metals, but astatine possesses some metallic character also. Fluorine and chlorine exist as gases. Bromine is a liquid at the room temperature. We know bromine is the only liquid non-metal. Iodine and astatine are solids. Atomic and ionic size. Halogens have the smallest size in a period. Their size is very small. If you take a period, halogens have the smallest size. Anyway, atomic and ionic size down the group increases. Ionization enthalpy, delta Hi. Because they have 7 valence electrons, they have tendency to gain electron only. They have very little tendency to lose electron. That means ionization enthalpy of halogens high. Anyway, down the group, ionization enthalpy decreases. Electronegativity. Because of 7 electrons in the valence shell, they have high electronegativity. Down the group, electronegativity also decreases. Electron gain enthalpy, delta Heg, energy released during electron gain process. Because of this electronic configuration, they have strong tendency to gain one more electron and attain the stability of octet electronic configuration. That means delta Heg value of halogens are large and negative. They release large amount of heat on electron gain. Down the group, delta Heg value decreases, means become less negative. Delta Heg value become less negative down the group. So we expect maximum negative value for fluorine, but for fluorine the delta Heg value is less negative than chlorine. That is, the order is maximum negative electron gain enthalpy is for chlorine. Then only comes fluorine, then bromine, then iodine. This is the order of delta Heg value. Delta Heg value down the group decreases, that is become lesser and lesser negative. But fluorine show an anomalous behavior here. The electron gain enthalpy of fluorine is less negative. The chlorine is more negative. This is due to the small size of fluorine. Fluorine, because of small size, the electron enter a smaller shell, second shell in the case of fluorine, which experience the added electron will get more repulsion. Hence, only lesser amount of energy will be released in the case of fluorine. Delta Heg value of fluorine is less negative compared to that of chlorine. An irregular observation shown by fluorine. If you compare the physical properties, all the halogens are colored. Here you can see fluorine is yellow in color. Fluorine is yellow. Chlorine is greenish yellow in color. Chlorine is a greenish yellow gas. Bromine is red in color. Iodine is violet. It's a violet solid. Astatine is black solid. If you compare the bond strength, or bond enthalpy of halogens, halogen single bond, we see that fluorine single bond is weaker than chlorine-chlorine single bond and also bromine-bromine single bond. This is due to the small size of fluorine. Fluorine, there are 3 lone pair electron. Here also there are 3 lone pair electron on chlorine and other halogens also. Because of small size, these lone pair electron, non-bonding electron pairs experience more repulsion. Due to more inter-electronic repulsion, due to the small size of fluorine atom, fluorine-fluorine bond is weaker than chlorine-chlorine or bromine-bromine bond. So the order of bond strength or bond enthalpy can be written as strongest bond is between chlorine atom. This is the strongest and highest bond enthalpy. Then comes bromine bond. Then only fluorine bond. Then iodine bond. This is the order of bond strength and bond enthalpy. That means bond strength, bond enthalpy highest for chlorine, Cl bond. Then bromine bond. Then only comes fluorine bond. This is the reason. More inter-electronic repulsion between the non-bonding electron due to small size of fluorine. Due to very small bond dissociation enthalpy of fluorine, the bond breaks very easily and produce F- ion. That is, fluorine is easily reduced. And this F- ion hydration enthalpy is very high. F- ion is stabilized due to high hydration enthalpy. Hydration enthalpy of fluoride ion is very high and low bond dissociation enthalpy of fluorine bond make fluorine the strongest oxidizing agent. Although delta Heg value is less negative for fluorine, the other two factors, which are the other two factors? Low bond dissociation enthalpy and high hydration enthalpy of fluoride ion make fluorine the strongest oxidizing agent. Fluorine, if you write the order of oxidizing power or the order of reactivity, fluorine is most reactive. It is the strongest oxidizing agent, and down the group among halogen, oxidizing power decreases. Reactivity also decreases. That means fluorine is more reactive than chlorine, than bromine, than iodine. Iodine is least reactive. Strongest oxidizing agent is fluorine. Weakest oxidizing agent is iodine. Why fluorine is strongest oxidizing agent? Because fluorine bond dissociation enthalpy is very low and fluoride ion hydration enthalpy is very large. Fluorine being strongest oxidizing agent, it can oxidize other halogens. For example, fluorine can oxidize chlorides into chlorine, bromides to bromine, iodides to iodine, itself undergoing reduction to fluorides. Similarly, chlorine can oxidize bromides to bromine, iodides to iodine, itself undergoing reduction to chlorides. Similarly, bromine can oxidize iodides to iodine, reduce to Br minus. So a higher oxidizing halogen can oxidize the lower oxidizing halogens. Okay, fluorine being the strongest oxidizing agent, fluorine can oxidize water to oxygen. It oxidizes water to oxygen. But other halogens, that is chlorine or bromine, when react with water, we get a mixture of hydrohalic and hypohalous acid. If chlorine, we get a HCl and HOCl, hypochlorous acid. If bromine, we get a HBr, hydrobromic acid and hypobromous acid are obtained. The reaction of iodine and water is non-spontaneous. That means no reaction under normal condition. In fact, iodide being the weakest oxidizing agent, iodides are oxidized by oxygen in acid medium. Oxygen oxidizes iodide to iodine. Anomalous behavior of fluorine. Fluorine, the first member, smallest size, highest electronegativity, highest ionization enthalpy, less negative electron gain enthalpy, weak dissociation enthalpy, show anomalous behavior. Its electronic configuration is 2s2 2p5. Only s orbitals and p orbitals are available for bonding. D atomic orbitals are absent. Fluorine is very reactive. In fact, most reactive halogen. Most of the reactions of fluorine are exothermic reaction because it forms strong bond with the other elements. Fluorine form only one oxo acid, that is HOF. That is hypofluorous acid only. But other halogens form many oxo acid. Fluorine forms only one oxo acid, that is HO. Not the only one oxo acid formed by fluorine is hypofluorous acid, also known as fluoric 1 acid. If we take the hydrides of halogen, compounds of halogen and hydrogen, we can write hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. These are the hydrides. These are called halides actually. Fluorides, chlorides, bromides, iodides. All the hydrogen halides are acids. If you compare the acidic character, acids are substances that can easily donate H plus ion. Here the bond, if you compare, before we discuss the acidic character, if we compare the bond strength or bond enthalpy, down the group size increases, electronegativity decreases. So both the bond strength down the group decreases actually. Means strongest bond is between HF. HF bond is strongest, stronger than HCl, than HBr, than HI. The HI bond is the weakest. HF bond is the strongest. So acidic character. So acidic character will be maximum in the case of HI because the bond is weakest, it readily breaks and donate H plus ion. HI is stronger acid than HBr, than HCl, than HF. HF is the weakest one. If we compare the stability, thermal stability of these hydrides also follow the same order as bond strength or bond enthalpy. That is, stability decreases. Acidic character, the order is just the reverse. HI is the strongest hydride of halogen.